Alright, so we have 3 lessons left total and 2 lessons left on permutations and probability and counting. So before we do that, I just want to go back 1 page, 2 pages. So I was kind of keeping track of the topics that we're covering. So in your last notes, you should have covered probability, which was our 6th topic. And then complementary events would be the 7th topic. So if you want to flip back a page and indicate those on the side. And then the 8th topic in those notes last time was odds. So that takes us up to 8 topics in this unit. Okay, so I just kind of want to make you aware of that. Keep track of those. There'll likely be a question of each type. So it helps if you're familiar with those. Okay, so moving on to today's lesson, which should be around May 3rd, 2021. And so our 9th topic in this unit is the probability of 2 independent events. Okay, so that's the probability of one thing is going to happen and then another thing is going to happen. And you know what independent means. When you're independent, you don't need help. You can handle things yourself. You're not depending on anybody. You're independent. So let's take a look at an example here. So we're not highlighting these examples because they're all possible test questions. Find the probability of selecting a heart and then replacing it in the deck and then selecting a face card. Why is the second event independent? So think about that for a moment. Why does the second event not depend on the first event? It's kind of obvious because it's underlined here. Because we replaced the card. So if we're putting the card back in the deck, now all the cards are in the deck. So it doesn't matter what happened the first time because all the cards are still available. Okay, so a heart. Hopefully you kind of, in the other notes we talked about the cards that are in a deck. And it's not about knowing how to play any card games or anything like that. We just, because there's a lot of different things in a deck of cards, we can use that as an example of how we calculate probability. So a heart, there are four suits in the deck. So that's going to be, and there's 13 in each suit. If you divide 52 by 4, 52 cards in the deck, so that's kind of the first thing you'd know. And then if you divide 52 by 4, you get 13. So there's 13 hearts in the deck of cards. Now, since you put the card back in, remember that the numerator is what we want, and the denominator is the total. Okay, so we don't have it on here, but probability is want over total. So we want a heart, and the total is 52. Now, we put the card back in, and then we want a face card. So face cards are jacks, queens, and kings. So there's 3 face cards in each suit, and there's 4 suits. So 3 times 4 is 12. So that's 12. Okay. Now, I would reduce this, which, if you think about it, if there's 4 suits, and we want to get a heart, which is one of 4 suits, we could have thought about this that way also. That it was 1/4 of the deck. There are 4 suits. Each suit has the same number of cards, so 1/4. But this reduces to 1/4. Okay, and this one, we can divide that by 4 also. So 12 divided by 4 is 3, and 52 divided by 4 is 13. So if we multiply that, that's 3 over 52. So that's about a 6% chance of that happening. Okay. Why is the second event independent? Because we put the card back. So all cards could be picked. So that didn't change the situation. Okay, So, the second question. A survey found that 7 out of 10 shoppers do not use coupons, and that 3 out of 8 shoppers only buy items that are on sale. If using coupons and only buying items on sale are independent, find the probability that a shopper selected at random uses coupons and only buys items which are on sale. Okay, that's a lot of words. That's a long question. So let's try to break it down a little bit here. So a survey found out that 7 out of 10 shoppers do not use coupons. But then down here, they're asking us about the probability that a customer does use a coupon. So the first thing maybe we should handle is we should take a look at that and think about what that means. Well, that's the complementary event. Complementary. So if 7 customers do not use, so 1, that's 100%. That's everybody. Minus 7 out of 10 do not use coupons, then this will be 10 out of 10. 10 over 10 minus 7 over 10 is 3 over 10. So 3 out of 10 do use coupons. So 3 out of 10 uses coupons and only buys items which are on sale. So this says only 3 out of 8 only buy items which are on sale. So that's the second event. Now it says that the events are independent. I would question that a little bit because I would think that there would be some relationship between people who use coupons and people who only buy stuff on sale. Like there's probably a connection there, but that's a little more complicated than we need to be in our class. We're just doing an introduction to probability. So you don't need to overthink these too much. Just go with the situation there. So none of these reduce from the top to the bottom, so we're just going to multiply. When you multiply fractions, you multiply straight across. So that's 9 over 80. So 8 over 80 would be 10%. So it's a little bit more than 10%. Okay? All right, so now we're on to a new topic, kind of. That was 2 independent events. Now we're talking about dependent events. So this is our 10th topic. Okay? So now, if we want the probability of A and B, given that they're dependent, we have the probability of A times the probability of B happening after A, because A is affecting B. So let's see. You have a bag of candy with 4 red, 6 green, and 3 brown candies. You randomly choose 3 candies from the bag. Determine if the events are independent or dependent. Okay? They're dependent. Why does it depend? The number of each candy changes when you remove one. So, and it would be easier to think about it maybe if different people were choosing candy. So if there was only one blue candy, and I reach in and pull out a blue candy, and now you go to get a candy out of the bag, now there are no blue candies left. So there's a 0% chance that you can pull a blue candy out of there if there was only one and I already took it out. Okay, so that's why it depends. So what is the probability that they choose all brown candies? Okay, well, the first time they reach in the bag, there are 3 brown candies and there are 13 candies total. So the first time you reach in the bag, you have 3 out of 13 chance. But when you go back into the bag, so now we have to adjust the probability because the situation has changed. So if we pulled out a brown candy the first time, now there's only 2 brown candies left in the bag because we already took one out. And now instead of 13 candies, there are only 12. So hopefully that makes sense. And now we're going to go back in that bag for a third candy. And we already took a brown one out twice. That means there's only 1 brown candy left. And now we're down to 11 candies total. Okay. So here, 3 goes into 12 4 times, and then 2 goes into 4 twice. And if we multiply straight across there, that's going to be 1. Oh, I don't know. How do you want to do this? 26 times 11, maybe? So that's going to be 0.6286. So not very good. About 1/3 of a percent. 1/3 of a percent. 1% divided by 3. Okay. New topic. Mutually exclusive events. Exclusive. They exclude each other. The word exclusive means people are excluded. If there's an exclusive club, then it excludes people. Maybe there's a expensive cover charge to get in. Maybe you have to have nice clothes, so that's going to exclude people. There's a dress code. If you don't have the right clothes on, you can't go. Stuff like that. Events with no common outcomes. So now if we're talking about, so the difference here is that those were both and, this is or. Okay, so both the last questions we were going to do one thing and then we were going to do another. Now we're saying we're going to do this or this. Okay. In that case, you add. If it's and, then you multiply. So notice how the word and right here, and we multiply right there. The word and right here, and we multiply. So and means multiply, and or means add, for the most part. Okay. I'm going to switch that up there so it's not in the way. Hopefully. Alright. So, a black 7. Well, there's clubs and spades. So there's 2 black 7s. So there's 2 out of 52. Or a heart. Now, a black 7 can't be a heart because hearts are red in decks of cards. And we're talking about a black card here. So a black card can't be a heart in the normal deck of cards. So that means that they're mutually exclusive. These are two. Getting a heart, or getting a 7, a black 7, is different from getting a heart. So now we can look at the hearts, and the hearts are 13 out of 52. Now, you might want to reduce this, but that would not be the good choice here because I'm about to add fractions, and when we add fractions, we want to have a common denominator. So, and remember, or is addition. So that's going to be 15 over 52. Okay? An even number. Well, that's 2, 4, 6, 8, 10. There are 5 even numbers in each suit, and there are 4 suits. So 5 times 4 is 20. So there are 20 even numbers out of 52 cards. Now those are both even, but I don't want to reduce them because I know that I'm talking about cards, and I'm going to have 52 cards over here as well. Now a king has a K on for the card, so that's not an even number. So no kings are even numbers. So these are 2 separate categories, 2 separate groups. Even numbered cards and kings. So they're separate. And there are 4 kings. 1 in each suit. So now we can reduce this. We can divide both of these by 4 at least. We know we can divide by 4 because there are 4 suits down here. So that's 13. And that does not going to reduce anymore. And this divided by 4 is 6. So that's almost 50%, a little bit less than 50% chance to get an even number or a king. All right. So let's look at our last topic for this notes, our 12th topic overall. And we're talking about mutually inclusive events now. So now some of the events are included. Not necessarily all of them, but some of them. So now, this is topic number 12 in this unit. Or, we said, was addition, but inclusive means we need to subtract. Because, so this Venn diagram helps us out. It shows that if these two events overlap, if I'm adding A plus B, we're counting these twice. They're counted when we added up the A's, and they're counted up when we added up the B's. Because the things in here are in both of those groups. So we're going to demonstrate what to do with that. Hopefully it'll be pretty clear. So we start off the same. We start off with a queen. So there are 4 queens in a deck of cards, and there's 52 cards. Okay? Now, we go over here and we start and we say, okay, we need to add the clubs. So there are 13 clubs. Okay, but there's a problem because one of our clubs is a queen. So what that means is we counted it twice. We counted it as a queen and we counted it as a club. So what we need to do is subtract out the overlap. And since there was only one card that was in both groups, we need to subtract 1. Okay, so that's 17 minus 1 is 16, so that's going to be 16 over 52, and then maybe 8 over 26, and then so I divided both those by 2, and then I divide by 2 again, so that's going to be 4 over 13. It's about a third, roughly. Okay. So, now would be a perfect time to pause the video and try part B, and hopefully even cover this up. Okay? Next year, when you're in class, when you're in your math class, try, when your teacher does an example, and the next example is kind of the same thing, try to do that example. See if you can do it. And then when your teacher does it, you see if you got it right. If you got it right, that means you're doing pretty well. If you got it wrong, it means, you got to try to figure out what happened. Okay, so red cards. So half of the cards are red. So we could put 1/2, but remember we're trying to keep a common denominator here because we're going to be adding and subtracting fractions. So I would just leave it 26 over 52. Half the cards are red. Or a 6. So there are 4 6s in a deck of cards. Now hopefully some of you are saying, wait a second, red cards, well there's 4 6s, but 2 of them are red and 2 of them are black. So 2 of those cards, the 6 of hearts and the 6 of diamonds, was counted here and here. So they were counted twice. So we need to subtract that out. So that's going to be 28 over 52. And I can divide that by 4. I'm just going to go directly to 4. And we could divide by 2 and divide by 2 if we needed to. But okay. So now, as a question gets a little more complicated, we can use a Venn diagram. These things up here, this is a Venn diagram. So we can use a Venn diagram to help us. So let's start by looking at the question. In a group of hospital patients, the probability of having high blood pressure is 3/8. The probability of having arteriosclerosis is 5/12. And the probability of having both is 1/4. So that means that there is a group that is affected by both. That means that if we just try to look at these probabilities, we're counting some people twice. So we need to fix that. Okay. So, and they're inclusive because some people have both. Now, we do a Venn diagram for this. We've got that, and we've got this. And I don't know if I'm not necessarily drawing this to scale. We don't have that on there. Okay, so we're going to try and construct a Venn diagram for this. So high blood pressure, we're going to call that high blood pressure. I'm just going to put an H for high blood pressure on that one. and then arteriosclerosis, I'm going to call that A, and then there was some that had both. Now, when we do this, it might be a good idea to try to get a common denominator already. So let's do that. So our three fractions were 8, 4, and 12, our three denominators, sorry. So 4 goes into 12, but 8 does not go into 12. So the way I do common denominators with three fractions is I take the largest number and I try to divide it by both of these. So I did the 4 works, the 8 did not. So now I'm going to take the multiples of 12. So the next, after 12, the next one would be 12 times 2, which is 24. So I ask myself, do all these numbers go into 24? Do they all go into 12? No. Do they all go into 24? 8 goes into 24, 4 goes into 24, 12 goes into 24. Yes. So my common denominator is going to be 24. Okay. Now, high blood pressure, 3 out of 8. So if 8 times 3 is 24, so 3 times 3 is 9. So that's going to be 9 over 24. Wait a second. No. I don't want to do that yet. Sorry. Okay, so the problem there was that the way I was writing that in, this excludes these. So I need to think about that a little bit more. So let's go back and let's just do the probability. So has either high blood pressure or arteriosclerosis. So that's going to be the 3/8 plus the 5/12 minus the 1/4, because 1/4 had both. That means they're counted both times, and we need to only count them once. Okay, so similarly there, we can think, I already talked about that. We know the common denominator is 24. So 8 times 3 is 24, so 3 times, so that's 9. Here that's times 2, so 5 times 2 is 10. And this is times 6, so that's going to be minus 6. So that's going to be 13 over 24. Okay? Now, what I want to do here is, what if the question said, how many have neither? Well, that would be the stuff out here. And the best way to find that would be to fill these things in like this. So there were 6 out of 24 who had both. Okay? And there were 9 out of 24 that just had high blood pressure. So I've already got 6 of those people in there, so the remainder of those 9 would be out here. So 3 people just have high blood pressure. So I hope you understand that. If you don't, you can ask a question, ask us. So the high blood pressure is 9 out of 24. But 6 of those 9 had both. So that means only 3 had high blood pressure by itself. And we can do the same thing over here. So there were 6 of these people in here. There were 10 people total who had arteriosclerosis. So this circle is supposed to represent 10 people. But we already have 6 of them inside here. But that means that there are 4 left over right there. And if we add those up, that's 13 out of 24, which we have here, which means this is 11 out of 24. It's just another way to look at it, to organize the information. So that's the answer to that question, would be 11 out of 24. And you could probably do that without a Venn diagram, but just saying, that might be helpful. All right, last one here. So, 6 children in our class, 4 girls and 2 boys. 4 children are chosen at random. Okay. What is the probability that at least 3 girls are chosen? So let's think about that. At least 3, that means that either 3 girls are chosen or 4 girls are chosen, to be at least 3. Right? If there's at least 3, that means there's either 3 or 4. So we could do 3 girls and 1 boy, that would be okay, or we could have 4 girls, that would be okay. This or this. Okay. This question is not directly related to mutually exclusive. It could be anything. Okay. So, if you want to choose 3 girls, and there are 4 girls total, this goes back to our first lesson, combination. Because for an exhibit, so the order doesn't matter. We're just who did you pick? So there were 4 girls, and we're going to choose 3 of them. And there are 2 boys, and we're going to choose 1 of them. Okay. Now over here, there are 4 girls, and we're going to choose all 4 of them. So if you, a combination is, you could set up the formula. It would be 4 factorial over 4 minus 3 factorial, which is 1 factorial times 3 factorial. But anytime you're 1 away from the endpoints, it's really just that number. So that's going to be 4. And this, since it's 1 away, is going to be 2. Now, if you don't remember that, then this is 4 factorial, and this is 4 minus 3 factorial times 3 factorial. So that's 1 factorial, which is just 1. And this is 4 times 3 factorial. So these 3 factorials are going to cancel out. We're just going to have 4 over 1, which is 4. Okay, so anyway, there's 8 ways to choose 3 girls and a boy. And if we come over here, if there's only 4, there's 4 girls total, and we want to choose 4 girls. Well, there's only one way to do that. You have to pick all 4 girls. That's the only way you're going to have all 4 girls in the exhibit. So there's only one way that can happen. So that is 9. Okay. Now, when we do probability, we're supposed to have what we want. So that's what we want. We either want 3 girls and a boy or 4 girls. There's 9 things, 9 possibilities for what we want. Now, the total, if we're calculating the total, there are 6 kids, and we're choosing 4 of them. Okay? So the formula, that is 6 factorial over 6 minus 4 factorial, which is 2 factorial, times 4 factorial. Combination, you always have this number, and then you always have the difference of those 2 numbers. So now, the numerator would normally be 6 factorial, but I can see a 4 factorial down here, and I don't want to write this out twice, so I'm going to write 6 times 5 times 4 factorial. So these are going to cancel. 2 factorial is just 2, so 2 goes into 6, 3, right? So that's 3 times 5 is 15. So that's going to be 15. And then that reduces, both those are divisible by 3, so that is 3/5. And that is it for that. Can't see the 5 there. Okay. Alright, it's about that time. Have a good day. 1 probability lesson left, and then 1 lesson left after that. Congratulations for being almost done. Hang in there. Let's get this done.